Are you excited to be gold digger to discover hidden insights in your numerical data? A bubble chart can reveal patterns that scatter plots alone might miss, helping you avoid common pitfalls like confusing correlation with causation. Therefore, as data scientists, contextual data analysis is necessary for making accurate decisions and avoiding misleading conclusions. In this video, we'll cover the basics of scatter plots, how to enhance them with bubble charts using Matplotlib, and their impact on business decisions. Stick around for a bonus tip on best practice design for bubble chart. If you have any questions, drop them in the comments and I'd be happy to help. Okay, let's dive in. A scatterplot is a data visualization that uses dots to represent the values of two variables. Each dot corresponds to a data point, with the x-axis representing one variable, such as age, ranging from 18 to 80 years, and the y-axis representing another, such as income, ranging from $20,000 to $100,000. The position of each dot helps reveal the relationship between these variables. For example, you might explore how income changes with age with following questions: do younger individuals earn less than older individuals? Or, is there a clear correlation? When interpreting the relationship, the scatter plot may reveal several patterns. First, a positive correlation, where income increases with age, often due to more experience or career progression. Second, a negative correlation, where income decreases with age, possibly due to retirement or reduced productivity. Third, no clear relationship, where points are scattered without any trend, often due to a confounding variable. A confounding variable is an external or third variable that affects and potentially distorts the relationship between income and age. For instance, education level could be a confounding variable in the relationship between age and income. Older individuals may have higher incomes not only because of age, but also because they've had more time to complete higher education, which often leads to higher-paying jobs. Without accounting for education, a scatterplot may show a misleading correlation. Therefore, scatterplots can show you the relationship between two variables, but they don't tell you why those variables are related. This is where a bubble chart comes in. By adding a third variable, such as education level, we can better contextualize the analysis and discover a more accurate relationship. This helps us see if correlation truly reflects causation, or if it's influenced by something else. Before we continue, if you found this video useful, don't forget to subscribe to my channel so you won't miss future tutorials and tips on how to apply data science and analytics in real business settings. Okay, let's continue. Let's move forward and create a scatter bubble chart using Matplotlib in Python. We'll be using the miles per gallon dataset from Kaggle, which has details about how different cars perform in terms of mileage. Now, feel free to pause the video anytime if you need to follow along with the code at your own pace. The dataset includes features such as horsepower, showing the power of the car's engine, miles per gallon, representing the fuel efficiency of the car, and weight, which will be used to determine the bubble size in the chart. First, we'll use the Seaborn package in SNS to load the dataset. Then, we'll clean it up by removing any rows that have missing data for the variables we're interested in, such as horsepower, miles per gallon, and weight. Second, we'll move on to plotting. We'll use Matplotlib scatter function to create the plot, with horsepower on the x-axis and miles per gallon on the y-axis. We'll make the points a bit more interesting by adjusting their transparency with the alpha parameter and giving them a nice white edge using the edge colors parameter. To add a third dimension, we'll represent the weight of each car by adjusting the size of the bubbles. We'll scale it down by dividing the weight by 10 so it fits better on the chart and doesn't overshadow everything else. Third, don't forget to label both x and y axes and to add a title to the chart. It'll make everything clearer and give the plot a neat finish. Looking at the scatter bubble chart, we see a negative correlation. As horsepower increases, miles per gallon decreases, meaning more powerful engines are less fuel efficient. If you look closer, the bubbles on the left for cars with lower horsepower and better miles per gallon are slightly smaller than those on the right for cars with higher horsepower but worse miles per gallon. However, the bubble size is currently based on the diameter, that is weight divided by 10, which can blur the audience. As a bonus point, let's adjust the bubble size based on the area that is proportional to the square of the weight, which is the standard data visualization practice of bubble chart. By squaring the weight and multiplying by constant value of 0.00001, we can get a more accurate size. Feel free to adjust the constant value until you get the right bubble size. Now, the effect is clearer. Smaller bubbles are on the left for lighter cars, and larger ones are on the right for heavier cars, making the relationship between miles per gallon and horsepower more obvious and compelling to the audience. Adjusting the constant value for the area of a circle affects the size of the circles. If the constant is set to 0.001, the circles will be too large and difficult to read. On the other hand, if the constant is set to 0.000001, the circles become too small to be easily visible. A balanced and more readable constant value would be 0.00001. You can try it yourself to see the difference. In the previous example, weight serves as a confounding variable affecting the relationship between horsepower and fuel efficiency in miles per gallon. Without it, you might wrongly assume that higher horsepower directly causes lower miles per gallon, displaying non-linear relationship curve. However, since correlation does not imply causation, the true relationship is more complex as weight also impacts fuel efficiency. How does confounding variable in cars' weight affect business decisions? In business, making decisions on incomplete or skewed data can lead to costly mistakes. For example, if a car manufacturer focuses solely on reducing horsepower without considering weight, they might make trade-offs that don't improve fuel efficiency while spending lots of resources. Reducing horsepower may only benefit lighter cars, while heavier cars could still struggle with efficiency. By accounting for weight, manufacturers can better identify specific products that need horsepower reduction and optimize designs for both cost and performance. Therefore, through weight variable, we gain a clearer understanding of how horsepower influences miles per gallon, revealing a more accurate relationship. Confounding variable provides context in data analysis where linear relationship between horsepower and miles per gallon is valid only for lighter car. Consequently, when communicating business insights, adding context through bubble chart makes the data analysis conclusion from numerical data more reliable and convincing to business stakeholders. This is how data scientists discover the so-called gold. Effective management of confounding variables enhances business decision-making in several ways. First, targeted interventions, identifying key drivers of outcomes enables focused improvements. Second, resource optimization, avoiding costly misallocations by addressing root causes. Third, data-driven storytelling, providing context-rich insights fosters stakeholder trust and understanding. Fourth, strategic competitiveness, data sophistication drives informed innovation and market leadership. Now, if you want to dive deeper into data storytelling with the Hollywood 3-act structure, make sure to check out the next video. I'll be sharing powerful tips on how to humanize data and turn complex data analysis result into something everyone can easily understand. Thanks for watching.